What if you could turn hours of call transcripts into concise summaries with just a few lines of code and without provisioning any server? Hey everyone, this is Hector from WebRTC.Ventures, and in today's video we will learn how to leverage AWS Lambda for building a serverless process that reads call transcripts from S3 and uses Llama 3 to obtain valuable call insights. Let's get started. Llama 3 is an advanced large language model designed for tasks like summarization, text classification, sentiment analysis, and more. It is an ideal option for contact center that process large volume of call transcripts. Amazon Bedrock provides a robust and scalable way for running these and other foundational models. It ensures efficient performance and affordable pricing. While Amazon Connect already provides these kinds of features by default through Amazon Connect Contact Lens, the approach described in this video provides a nice alternative for cases when, for whatever reasons, you are not able to use Contact Lens. The first thing we need is a bucket where to upload call transcript files. This is where your application or transcription pipeline should put this. In my case, I'm gonna use the same one from our previous transcription video. Now let's create the Lambda function by clicking the Create Function button. Let's name this function Get Call Summary and select the Python runtime. Let's scroll down and go with a Lambda execution role with basic permissions. And finally, let's click Create Function. Now let's give the function proper permissions. At the very least, we need to grant the function access to Amazon Bedrock and to the S3 bucket. To do so, let's go to Configuration and then Permissions. Then let's click on the role name. On the other tab, let's click on Add Permissions and then Create Inline Policy. Under Service, let's choose Bedrock. And under Actions, let's search for Invoke Model. For this action, we need to specify the model we would like to grant permissions to. In this case, we want to access Llama 3. So I will add an ARN, I will pick any region, and I will paste the ID of such a model. Then let's click on Add ARNs, and then click on Next. Let's name this policy Amazon Bedrock and click on Create Policy. Now let's do the same for S3. Click on Add Permissions and then Create Inline Policy. We select the S3 service and add Get Object as the action. Let's also add an ARN and paste the name of the bucket. In this case, this is the name of my bucket. I will check the Any Object Name checkbox to grant access to any file in the bucket. Now let's click on Add ARN and then click on Next. Let's name this policy S3. And finally, let's click on Create Policy. Now let's get back to the Lambda tab and start writing the code. So let's click on Code. Let me paste the code that I will use. We begin by importing the required libraries. Then we initiate the clients for interacting with the AWS services. Next, we get the file and bucket names from the event that triggered the function and use these to retrieve the file from the bucket. In my case, I'm getting the transcriptions from Amazon Transcribe. So I parse the content of the file using the JSON library and access the transcript under multiple JSON keys. Next, I define the prompt for Llama. In this case, I'm keeping it simple, but you can adapt this to your particular use case. Then we make the request to Amazon Bedrock. We pass the ID of the model, Llama 3 8B in our case, the content type we send and expect, and the prompt we previously defined. Finally, we parse the response from Bedrock and get the summary from the generation key. For this video, we will print out the summary in the AWS Lambda logs, but you'll want to send these to either your application or as a new file in S3. So let's deploy this function. The next step is to define a trigger for this function. To do so, let's click on the Add Trigger button and select S3 as the source. Then select your bucket. And since, in my case, all my transcripts live under the call transcript prefix, I need to add it here. Call transcript. Also, even if my transcripts are in JSON format, they are stored as TXT files, so I also specify that. So let's acknowledge the warning and click Add. So let's test our Lambda function. To do so, let's manually upload a call transcript to our bucket. In a real-world scenario, this will be managed by your application or as a result from an Amazon Transcribe transcription job. So let's click on Upload, click on Add Files, look for the file that I want to add, and then click on Open. Finally, let's click on Upload. Then we can click on Close. So after doing this, the Lambda function should trigger automatically, get the file from S3, and make the request to Amazon Bedrock. Okay, so when recording this video, I ran into a couple of issues that I will explain here. The first one is that the Lambda function timed out after 3 seconds. This is because Lambda functions has a default timeout of 3 seconds. So what I did is that I increased this timeout to something like 1 minute. You can adapt this to whatever works for you. And also, when creating the trigger, I got a typo while writing the prefix. So if you have a similar issue, you can simply remove the trigger and recreate it. After the function is done, we can go to the logs and see the summary returned by Llama. And there you have it. We've shown you how to build a Lambda function to read call transcripts from S3 and summarize them using Meta Llama 3 on Amazon Bedrock. With this setup, you can efficiently process large volumes of call transcripts and extract valuable insights easily without having to provision a single server for it. Ready to get the most out of your call recordings? At WebRTC.Ventures, we are experts at building high-quality, real-time communication apps that implement AI features and integrate with services like Amazon Bedrock. Contact us to know more about our services at WebRTC.Ventures/contact. Be sure to follow us on LinkedIn as WebRTC.Ventures, and don't forget to subscribe to this channel for more WebRTC tips. Let's make it live!